Hi everybody, Dr. Tobolowsky here again, and we are ready to begin Experiment 6. Experiment 6 is a bit like Experiment, was it 3? In that we're going to be making a lot of observations about things that we see, observations and conclusions. So this isn't one of those calculation type lab reports. This is one where you're going to watch and enjoy the beautiful sights of chemistry. The first beautiful sight of chemistry is a dangerous instructor demo. So again, it's a nice thing that you're there watching at home and nowhere near us, because the first demo is literally fire and brimstone. We're going to start by combining sulfur with powdered iron. So this is like just finely divided iron in there. It just looks like a gray powder. And I mixed some of these two substances together already in a test tube. And so you can kind of see we've got some of the iron powder, and then you can see some of the yellow sulfur in there. The iron is magnetic, but the sulfur is not. So you could technically separate this mixture using a magnet. Okay, but like I said, this is fire and brimstone, not play with magnet day. All right, time to heat this up. What's actually happening here is a combination reaction. So we're seeing iron solid plus sulfur solid is going to iron sulfide, FeS solid. And you can see that it's sort of glowing, suggesting this might be an exothermic reaction. And while it's still hot, I'm going to drop it in this cold water. Did the thermal shock break the test tube? Yes, it absolutely did. So that's actually a good safety lesson. Whether you're in the kitchen or in the chemistry lab, it's never a good idea to drop hot glass in cold water. You could definitely injure yourself. Okay, let's see what we were able to fish out of here. Looks like we've got a little bit of the iron sulfide. And you can see it's kind of a black solid, kind of silvery in nature. I'm going to try and get a little bit of it there. Okay. It looks kind of like a black solid. I'm going to go ahead and put some of this in a test tube. And so that was experiment 1. Now let's begin experiment 2. So I'm going to add a few drops of 6 molar HCl into that iron sulfide solid. So FeS solid plus HCl aqueous. If you look closely, what do you notice? What is that evidence of? That's right, it's bubbles. One of our signs of a chemical reaction. And if you were to smell this gas that's coming off right now, it would smell like rotten eggs. It's hydrogen sulfide gas. So this reaction in part 2A is going to be FeS solid plus HCl aqueous produces H2S gas plus FeCl3. Okay, now it's time to do part 2B, and I'm going to take some of this lead nitrate, hook it up with my little dropper here, and put some on some filter paper. This is just a piece of cut up filter paper. And I'm going to hold it over the mouth of the test tube. The mouth of the test tube means the top of the test tube. And watch that filter paper. Wow, it's changing to that dark color. So what's actually happening here is actually a reaction at the surface of the filter paper. So hydrogen sulfide gas plus lead nitrate aqueous produces lead sulfide solid. Black solid here is lead sulfide solid plus, can you guess what the other product is? Use your knowledge of double displacement reactions. So again, I'll say it one more time. Hydrogen sulfide gas, H2S gas, plus lead nitrate aqueous produces lead sulfide solid plus what other product? I'll let you figure that out in your post-lab. All right, it's time now for experiment 3. In experiment 3, we're actually going to be fishing out a little bit of the sodium metal here. So this is sodium chunk in oil. And you can see it's kind of like a soft metal. It's kind of shiny, but I can actually cut it with a knife. So you can see it's kind of shiny and you can cut it with a knife, and it does have that oil in there. And the reason it has oil is because it reacts with water. And what is there a lot of in the air? Yes, even in Los Angeles, our desert air has water, which will decompose the sodium over time. So what are we gonna do? Well, we're gonna drop it in water. What else would we do? For fun, I'm gonna add a little bit of phenolphthalein. Phenolphthalein turns pink in the presence of a basic solution. And when we add sodium to water, we will make a basic solution so we can watch that color change. All right, here we go. All right, time for reaction 4. This one involves very poisonous, actually. So again, another good reason for you to be at home. This is a chromium compound. It's ammonium dichromate. You can see the formula there. And I'm gonna put some of this beautiful orange compound in a test tube. You can see it's got that really nice orange compound. I'll put a little bit more in. I'm feeling a bit dangerous. Okay. And now what we're gonna do is just heat this up over the Bunsen burner. Now for this one, don't worry about writing the reaction formula in your notebook. Just skip this one. This one's just for fun. So don't worry about the reaction formula. There you go. You see it pretty much grows about 10 times in size. That's why I was nervous to add too much, because you can very easily just fill this test tube up with the product of this reaction, which has definitely grown in size. Okay. Time for reaction 5A. So reaction 5A starts with a piece of magnesium metal. This looks kind of like a boring piece of metal. And we're going to go ahead and burn it in the Bunsen burner. See, it gives off a very bright white light. And I'm collecting the ashes inside of a beaker. Got some nice white ashes in there. Early chemists, or should I say alchemists, were always very interested with ashes because ashes actually weigh more than the substance you burn, and that was confusing to early chemists because why would something weigh more after you burn it? Well, the answer is that it has to be combining with something. I won't say any more. I'll let you figure that out for this reaction. Time for part 5B. We're going to just add a little bit of water to our magnesium ash. Try and dissolve all that nice white ash. And I can see in there that there's some undissolved magnesium metal that didn't burn. And now I'm going to add a few drops of phenolphthalein. If you see a pink color, if you remember, what does that indicate? So just to recap, in reaction 5A, we took magnesium when we burned it. That created an ash. I'll let you try and figure out what the chemical formula is for that ash. Then we took the ash and added water to it. Then the products, well, we're not sure what the products or product is, but what we do know is that when we add phenolphthalein, the solution becomes pink, which indicates that there's probably what type of ion present. What does phenolphthalein detect? I'll give you a hint. It detects hydroxide ions. So using that information, try and figure out what the product is for part 5B. All right, we're gonna do reaction number 6. I'm gonna take some iron. Just a few pieces of iron wire. And I'll just put all 4 in there, why not? 4 pieces of iron in the bottom of a test tube. And then to that, I'm gonna add some of the copper sulfate solution. Add about 20 drops just to fully cover that iron. Okay, so now I've added some copper sulfate to the iron, and we're gonna go ahead and let that sit for a while. Okay, so while that one's resting, we're gonna go ahead and do number 7. For number 7, we're gonna take a piece of copper metal. Here's a nice shiny piece of copper metal. It's got that nice brown coppery color. Put that in a test tube. And to this, I'm gonna add some silver nitrate. About 20 drops. Just to fully cover the copper. Okay. And we'll let both of these sit for about 20 minutes, approximately. It doesn't have to be exactly, so I'll put this down. And we'll check back in on reactions 6 and 7 in a little bit. Okay, we're revisiting now reaction number 6. Take a look at the iron. Notice that it's changed colors. What is coating the iron? What sort of reaction is this? And now let's go ahead and revisit reaction number 7. This is reaction 7. Oh, wow. So we've seen a major change here. Remember, there used to be a piece of copper in here. I don't even see that copper at all anymore. And instead, I see this nice silvery solid. I wonder what reaction occurred here. Time now for reaction number 8. We start off with a little bit of zinc scraps. So they're kind of like thin angel hair pastas of zinc metal. So watch carefully as I add some hydrochloric acid. What do you notice about the products of this reaction? I'm going to take a little burning splint here and hold it over the roof. Did you see that? All right, so now it's time for reaction 9A. It begins with some copper sulfate pentahydrate, and I put some of the blue substance inside this test tube. And what we're going to go ahead and do is heat it up, as the instructions say. Watch that blue color, see if you notice a change. Notice a change occurring, a chemical change occurring. Okay, I'll give you a hint. I'll give you 2 hints, actually. This reaction is similar to a reaction we've seen in a previous experiment. And also, this reaction, 9A, is considered a decomposition reaction. Now, reaction 9B asks, is the dehydration of copper sulfate pentahydrate reversible? So let's see if this one is reversible, and we'll have to use our powers of observation to try and make that determination. I'm going to add some water to the test tube, and let's see what happens. Obviously it boiled because the test tube was very hot, but what do you notice about the substance now? What do you notice about the substance now? Do you think this process was reversible? Do you think dehydrating the copper sulfate is something that is reversible? Could we do it again? Okay, so we're gonna start now with reaction 10. In reaction 10, we're gonna add several drops of dilute nitric acid. So this is the nitric acid right here. I'm going to add several drops to a well plate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That sounds good. 11. One more just for fun. Sort of spread it around here. And now I'm going to add some sodium hydroxide. Sodium hydroxide looks like this. And I see a little bit of smoke wafting. Do you see that? And I'm going to feel underneath. And it definitely feels warm, indicating this is an exothermic chemical reaction. And now let me apply some litmus paper, and we'll see if the resulting solution is acidic or basic. So blue litmus paper turns red in the presence of acid, and red litmus paper turns blue in the presence of base. So depending on whether I added more nitric acid or more sodium hydroxide, that'll determine whether our resulting solution is acidic or basic. So it looked to me kind of like I added a little bit more nitric acid than sodium hydroxide. So I predict the solution will be acidic. So what do you think the result will be when I dip these 2 pieces of litmus paper inside? Aha, I was right. The blue litmus paper turned red, and the red litmus paper didn't do anything. So what does that tell you about the result? What does that tell you about the result? Time for reaction 11. We're going to take some lead nitrate, aqueous, and sodium sulfate, aqueous, and we're going to mix them together. Here we go. Here comes the sodium sulfate now. What do you observe? What can you conclude? Hint, you may want to check out the solubility table for this one. Okay. We're going to start with some drops of lead nitrate. This is going to be reaction 12. And then to the lead nitrate, I'm going to add some ammonium sulfide. This one smells like rotten eggs. Real nasty. What can you observe? What can you conclude? All right, finally in reaction number 13, and a few drops of cadmium nitrate. So this is aqueous cadmium nitrate. I'm going to add some of that same ammonium sulfide to the cadmium nitrate. What can you observe? What can you conclude?